In exercise 703, we actually move on from being able to calculate gradient or find the y-intercept to actually having a look at why do we do those things? Whoever uses this, and what's the significance of these values that we find? So, yes, there's been a lot of emphasis on finding the gradient, finding the y-intercept, but now we look at why we actually do that. And this aspect of the chapter is called linear modelling. So linear, because yes, we will talk about the gradient and y-intercept. Modelling meaning based on a model in real life. So based on a real life model, what would gradient represent? What would the y-intercept mean? We know that scientists and researchers often use linear functions to describe patterns they observe. So you may have wondered and often heard the comment, when am I ever going to use my algebra? Well, it's probably because you're not in contact with scientists and researchers. However, if you were, then you would know that they use their algebra daily. So there's some terminology. There are some words that you have to know have a good understanding of their meaning. You know that the equation for linear functions now, or a linear relationship, in its equation form, it's in the form y equals mx plus c. It's going to be the m and the c that we are going to understand the interpretation of those two, m and c. Now, for us to do that, like I said, you have to be familiar with the terms dependent and independent variable. So they are what the x and y represent. Now, because y depends on the value of x, y is the dependent variable. And then it makes sense that x is the independent variable. So you may be looking at doing some research into whether you should buy some taxi number plates and start up a taxi business. So you might want to look at the number of people moving into the area. So you collect your data, about the number of people new to the area or leaving the area over a given period of months. And if you were to find that in time and the population, you're actually finding it was doing this, you would probably realise that maybe it wouldn't be a good idea to start up a taxi business. Why not? Because you can see the population's coming down. Now, we can see that that line has a negative gradient. What does that gradient measure? It measures the decrease in population. For example, if this was months, so what it's actually measuring is the decrease in population per month. We say that gradient is a rate. It's a change in a variable compared to another variable. So the change in population compared to months. Now, the independent variable in this example is the time, independent, and it's the population that's depending on the time. We've previously called this the x-axis or the horizontal axis, and here it says that the independent variable is placed on the horizontal axis. And you can see then the dependent variable is placed on the vertical. Dependent is like y. So these things that you really have to put an effort into learning. Y is dependent, X is independent. If you learn that off by heart, that will help you when it comes to drawing a graph and interpreting the gradient. So you can see here a variation of our X and Y in that we're calling the Y-axis the dependent axis, or the values for our dependent variable, and the X-axis is our independent variable. Really important that you get those two names sorted because you're going to see them written, and you need to be associating the words independent with the appropriate axis, with the appropriate letter in the formula, etc. You can see here it says the gradient measures the slope of the line. We know that. We've looked at that. That's been the focus for quite a long time, that the gradient is the slope. However, we're moving on. We're developing further our understanding of this value of the gradient that we're able to calculate now. It measures or represents the rate. I can't emphasize that enough. The rate at which the dependent variable is changing. You can see I wrote it here, that gradient is a rate. I often find that maybe this is the first time that you're being told that the gradient is more than rise over run. It's really only rise over run when we're looking at a graph. That's not where the scientists and the researchers stop. They don't just make graphs and walk away. They make graphs so that they can interpret what's going on and use that then to make predictions for the future. So now when you're asked about the meaning of the gradient, you're going to be expected to give a worded description of the gradient. Let's have a look here at this first example. And it's about the cost of producing some items. We can see that this line has a positive gradient. When you're asked what does the gradient represent, you don't say rise over run anymore. We know that our dependent variable is cost, our independent variable is the output. We describe the gradient as the change in the dependent variable compared to the independent variable. So in this case, we would say we can see there is a positive or an increase in the cost as the output increases. There's an increase in the cost. Over here with this line, with this function coming down, and it's talking about comparing the price to the quantity, so we might be purchasing items, and we can see if we only purchase 50, it's going to cost $5. If we're going to purchase 250, then it costs $1. So how do we interpret? We know it's a decrease because the gradient, we can see the lines going down, the gradient is a negative. Then we can say that there is a decrease in price per item purchased. You know that the y-intercept, you've called the y, or you've been asked to identify the y-intercept. You would call that or identify that as where the line cuts the y-axis. No, in talking about what it represents, we've got to talk about real things here. So y-axis doesn't have any application in the real world. What is being measured here in the real world, in this situation, is cost. So the y-intercept is the initial cost of producing something. So we can see it's almost $8,000. That means it's going to cost $8,000 to get all set up to be able to start production. So that's our interpretation now of the y-intercept. No longer do we just say it's where the line cuts the y-axis and give a number answer. Yes, we will give a number answer, but we'll put it in the context of what the data is representing, what the dependent variable actually is. I think I'll stop the video there and do the example in the next video.